This is the Algebra Semester Exam Review on Unit 2, Topic 1, which is questions 20 through 29. Remember that when you are given the exam, you will have this formula sheet, so it's always good to know and understand everything that's on it in case you need it during the exam. Question 20. The graph below shows the price of a pizza with up to 4 toppings. So we have our number of toppings on the n-axis and the price of the pizza on our p of n axis. So relate the variables using the expression is a function of. So remember, y is always a function of x, or in this case, p of n is always a function of n. So the price of a pizza, which is our y, is a function of our x, which is the number of toppings. Part B says, use function notation to describe the point 2, 1250. Well, function notation says p of n, which in this case, n is going to be 2, so p of 2 equals what p of n is, which is 1250. So this is function notation to describe the point 2, 1250. Next, we're asked, what is the domain of this function? Well, looking at our points, we have when n is 0, 1, 2, 3, and 4. So that is going to be our domain. Because it's discrete, we're going to put braces. And we're going to have 0, 1, 2, 3, 4 in braces. Next question. Do these points describe a linear function? Why or why not? Well, if we look at this graph, we can see that we're going up by $1, then we're going up by 75 cents, 50 cents, 25 cents. So, no, it is not linear because there is not a constant increase in the price for each topping. So for it to be linear, the price would have to change at a constant rate every time we add on another topping. But since it doesn't do that, it's not a linear function. Finally, it asks for what the range is. Again, since it's discrete, we need to have braces, and we can look at our graph and see 1075, 1175, 1250, 13, and 1325. So we'll write that as our range, 1075, 1175, 1250, $13, and $13.25, and that is our range. Question 21 says you are playing a Carnival game. You now have 50 prize tokens. Each time you win a game, you will get 8 prize tokens. As soon as you get at least 100 prize tokens, you will stop playing. The function t of w equals 50 plus 8w represents the total number of prize tokens that you have after winning W games. Fill in the missing values in the chart below. So we know that we have t of w. In this first case, we want t of 0. So that's when w is 0. So we'll have 50 plus 8 times 0. And 8 times 0 is 0, so 50 plus 0, which equals 50. So we know t of 0 is going to be 50. Next we're going to do 2, so t of 2. And that's when we have 50 plus 8 times 2, because w is 2. So this is 50 plus 16, which is 66. So t of 2 is 66. Now this last one requires us to find w. So we know t of w is going to be 82. So we're going to plug that into t of w in our equation and get 82 equals 50 plus 8w. I'm going to subtract 50 on both sides, which is 82 minus 50 is 32. And that's going to equal 8w. To get w by itself, I'm going to divide by 8, and w equals 4. So when w is 4, t of w is 82. Our next question is, what are the independent and dependent variables? Well, the independent variable is our x, it's our w. And w stands for how many games you won. So our independent variable is going to be number of games won, which is w. Our dependent variable is what depends on the number of winning games, and that would be t of w, which is the total number of prize tokens. So our dependent variable is number of prize tokens, which is t of w. Next thing we're asked to do is relate the variables using the expression is a function of. So remember, y is a function of x. So the number of prize tokens, that's our y. So the number of prize tokens is a function of our x, which is the number of games won. Part D asks, are the variables discrete or continuous? Why? So remember, discrete means you can't have part of it. It's individual numbers. Continuous means it's everything in between two numbers as well as those numbers. So, real numbers. So in this case, the variables are going to be discrete. The reason why is you cannot have a portion or a part of a prize token. So you can win 1 prize token or 2 prize tokens, but can't win half a prize token. And you can't win part of a game. Oops. Can't win part of a game. All right, you can win 1 game, 2 games, but you can't really win 1.5 games. So they must be whole numbers only. All right, part E says, what does the statement t of 3 equals 74 mean in this situation? Well, remember, 3 is going to be our w, which is the number of games won, and t of w is the number of prize tokens, which is 74. So this statement means the number of prize tokens that you have after winning 3 games is 74. Next, it asks us to complete the domain. It starts us at 0, 1, 2, but we have to figure out how far we're going to go up. If you remember in the situation, it says, as soon as you get at least 100 prize tokens, you will stop playing. So, we've got to figure out how many games are we going to win to get 100 prize tokens. So we know our formula is 50 plus 8W, and we want to know when is that going to equal 100 or greater. So I'm going to take away 50 first, and that's going to give me 8W equals 100 minus 50, which is 50. I'm then going to divide by 8 and get W equals 50 divided by 8, which is 6.25. So 6 games will have us still under 100 prize tokens, but once I start playing that the game after the 6th one, I'm going to reach my 100 tokens. And it's okay to go over 100 tokens, but I can't go past that. So, and what I mean by past that is after my 7th game, I'm going to stop because I already have 100 prize tokens. So my domain is going to be 0, 1, 2, 3, 4, 5, 6, 7. And I'm going to stop at 7. Finally, what number would replace the variable W in the statement T of W equals 90? Well, this is where we're going to have 50 plus 8W, that's our expression, and we want to know when does that equal 90. So I'm going to take away 50, and I'm going to get 8W equals 90 minus 50, which is 40. I'm going to divide by 8, and W is going to equal 5. So the number that would replace W is 5. Question 22. Look at the graph below. Which of the following points, if added to the graph above, will cause the relation not to be a function? Well, let's start adding them to the graph. A is 2, 3, so that's going to be right here. B is 1, 2, 3, 4, 2, which is right there. C is 3, negative 2, which is right here. And D is 0, negative 4, which is right there. For it to not be a function, that means that there's got to be an x that has more than one y associated with it. Well, we can see right here when x is 3, we'd have 2 y's associated with it if we put point C on the graph. So point C is going to cause the relation to not be a function. Question 23 says, which of the following statements is true about the statement f of 5 equals 12? So part A is the point 5, 12 is on the graph of the function. Well, that's going to be true because this is x, this is y, so I can get the point 5, 12. But let's go through B and C just to make sure we're clear because you want to make sure that you haven't made a mistake. The number 5 is an element of the range of f. Well, 5 is actually an element of the domain because it's our x, so that is not true. C says 12 would be the value of the independent variable, that would be our x, and 5 would be the value of the dependent variable, which would be our y. This is not true. 5 would be the value of the independent variable, and 12 would be the value of the dependent variable. Or 12 would be the value of the dependent variable, and 5 would be the value of the independent variable. Either way, we know C is not true either, so the answer is A. Question 24. If f of x equals 3x minus 2, what is the value of f of 5? Well, f of 5 means that x is going to be 5. So f of 5 is going to equal 3 times 5 minus 2. Well, 3 times 5 is 15, and 15 minus 2 is 13, so my answer is going to be B, 13. 25 asks us to sketch a graph on the axes below for function f of x with the following characteristics. So first of all, the function has x-intercepts of -3 and 2. This means we're going to have a point at -3, 0, because an x-intercept is when y is 0 and 2, 0. The y-intercept is 3. That means we're going to have a point at 0, 3, because a y-intercept is when x is 0. The next bullet says f of negative 4 equals negative 5. Well, negative 4 is going to be my x, negative 5 is going to be my y, so I'm going to have the point negative 4, negative 5. I also have f of 4 equals negative 3, so I know that there's a point 4, negative 3 on my graph. Let's start plotting these points. We have negative 3, 0. We have 2, 0. We have 0, 3. We have negative 4, negative 5, which is all the way down here. We have 4, negative 3. And those are the first 3 bullets. The next bullet says the function has a maximum value at the point negative 1, 4. So we know this is also a point on our graph. Now it says the function is increasing. That means when we read the graph left to right, it's going up. When negative 4 is less than or equal to x, which is less than or equal to negative 1. So this is negative 4, this is negative 1. So my graph is going to be increasing in this section. That means we're going to have a graph that looks something like this. It then says it's decreasing when negative 1 is less than or equal to x, which is less than or equal to 4. So here's negative 1, here's 4. That means my graph is decreasing in this section. Finally, the next bullet says the domain of the function is negative 4 is less than or equal to x is less than or equal to 4. So that means I'm going to stop at negative 4 and 4, so no arrows. And the function is continuous, which means I connect all of these points the way my graph is now. And that would be my graph. Question 26 says the graph below represents the temperature F in degrees Fahrenheit inside of a freezer as a function of time. The variable T represents the time in hours since midnight. So we have our graph, and our first question is, what is the domain of the function? Well, the domain is all the values of x that this graph covers, which is between 0 and 7. So our domain is going to be 0 is less than or equal to t, which is less than or equal to 7. You can also write it as 0, 7 with brackets because it includes 0 and 7. Part B asks what the range is. So the range goes from our lowest y value to our highest, so from negative 3 to 3. So we have negative 3 is less than or equal to f, which is less than or equal to 3. And notice I'm getting these from T, time in hours, and F for my degrees in Fahrenheit. We can also write it as negative 3, 3 with closed brackets again. Part C asks, what is the meaning of the F-intercept? Well, the F-intercept is right here. That's when T equals 0. So the F-intercept is the temperature at midnight. So it's when T equals 0. The reason why it's at midnight is if we go to the top of our problem, we see that the variable T represents the time in hours since midnight. So 0 is midnight. Part D says at what time T is the minimum temperature reached? Well, our minimum temperature is right here at negative 3, and that's at 6. So it's reached when T equals 6, or 6 hours after midnight, which really is 6 a.m. Part E asks, on what interval of time is the temperature decreasing? Well, looking at our graph, we read it left to right, so we're increasing up to this point, and then we're decreasing down to this point before we increase again. So we're decreasing from 3 to 6. Now, I usually don't include those points, 3 and 6, because I think at those points they're neither increasing nor decreasing. So I would say 3 is less than t is less than 6, or I could write it as 3 comma 6 with parentheses instead of brackets because they don't include them. But you wouldn't lose points if you also wrote 3 is less than or equal to t, which is less than or equal to 6, or 3 comma 6 in brackets. Either answer is acceptable. Finally, the question asks, what does the statement f of 5 equal negative 2 represent in the context of the situation? Well, our x value, that's our t. T being our time and hours after midnight. So 5 hours after midnight, and then this f gives us our temperature. So 5 hours after midnight, which is same thing as 5 a.m. The temperature of the freezer is negative 2 degrees Fahrenheit. And that's what f of 5 equals negative 2 represents. 27 says, for each relation below, determine whether or not the relation represents a function. Justify your answer. So, if we remember, the definition of a function is that for every x, there's only one y. So if we look at this graph, every x on here only has one y. All right, so the relation is a function. Because for every x, there is only one y associated with it. For part B, we can see that when we're going along, there's certain x values that have more than one y associated with it. For instance, if I put in x equals 1, I don't know which of these three answers I'm going to get. So B, the relation is not a function. And this is because several x values, like x equals 1, have multiple y values associated with it. So it is not a function. Part C says we have the points 2, 7, 4, negative 7, 2, 12, and 6, 11. And what we can see from here is that the relation is not a function. And the best reason why is to give an example. The relation is not a function because when x equals 2, there are two y values associated with it. Which are 7 and 12. I'm going to rewrite that. 7 and 12. So C is not a function. Part D gives us 4, 9, 6, 11, 11, 15, and 10, 9. Therefore, the relation is a function. And this is because for every x, there is only one y associated with it. So it is a function. For part E, we have this graph where we have x values of 4, 2, 5, 4, 5, 8, and 7, 9. So we can see right here that the relation is not a function. When x equals 5, there are two y values associated with it. And they are 4 and 8. Finally, we have part F, and we can see that the relation is a function. For every x, there is only one y associated with it. Therefore, it is a function. Question 28 gives us the graphs of two functions, f of x and g of x, which are shown below. For each problem, A, B, and C, write the correct symbol, less than, equals, or greater than in the box between the two statements. So we're going to do f of 2 and compare it to g of negative 1. Well, here's my f graph, here's my g graph. So f of 2 is going to be this point right here. So f of 2 is going to equal 3. G of negative 1 is this point right here, which also equals 3. So these two values are equal. Our next one is the x-intercept of f of x. X-intercept is where it crosses the x-axis, so that is right here. When x is, when x is negative 1. The y-intercept of g of x is right here, which is when it equals 4. So the y-intercept of g of x is greater than the x-intercept of f of x, or the x-intercept of f of x is less than the y-intercept of g of x. Finally, we have f of 1 times f of 3. Well, looking at that, f of 1 is right here, and f of 3 is right here. So f of 1 is 2, and f of 3 is 4, and 2 times 4 is 8. On the other side of things, we have g of negative 1 plus g of 2. Well, g of negative 1 is right here, and g of 2 is right here. They both equal 3, so we're going to have 3 plus 3, which equals 6. Since 8 is greater than 6, f of 1 times f of 3 is greater than g of negative 1 plus g of 2. Question 29 gives us two functions, f of x and g of x, that are represented below. We're being asked to compare the statements in column A and column B. In the empty space at the end of each row in the table, write the column letter A or B of the expression that has the greater value. If both expressions are equal, write an equal sign. So first of all, we're going to look at f of 1. This is our graph for f of x. This is our graph for g of x. So f of 1, that's when x is 1, that's going to be equal to 2. G of negative 3 is on the graph when x is negative 3. That's right here when it equals 1. So which is greater? Column A. The maximum value of f of x, well, that's the largest value of f of x, which is going to be right here at 9. So the maximum value of f of x, that's 9. The x-intercept of g of x, that's when y is 0. That's right here when x is -2. So which one's greater? Column A again. Our next question has f of 0 minus f of 4 divided by 4. Well, f of 0 is 8, f of 4 is 0. So this is going to be 8 minus 0 divided by 4. 8 minus 0 is 8, and 8 divided by 4 is 2. G of 2 times G of 4, well, G of 2 is right here at -3, and G of 4 is right here at -2. So this is going to be -3 times -2, and -3 times -2 is 6. So which one is greater? Column B. For our next one, we have the value of x that makes f of x equal to 0. Well, when is f of x equal to 0? Right here when x is 4. So this is going to be equal to 4. And then we have g of -5 plus g of -3. Well, g of -5 is 3, and g of -3 is 1. So g of -5 we said is 3 plus g of -3, which is 1, and 3 plus 1 is 4. So they are equal. Finally, we have a plus b if f of a equals 5 and f of b equals -10. Well, when does f of x equal 5? F of x is going to equal 5 when x is -8. So f of a equals 5 when a is -8. All right, and then we have f of b equals -10. Well, that's when b is 7. So f of a equals 5 is -8. F of b equals -10 is when b is 7, and -8 plus 7 is -1. For g of 4, that's when it equals -2. So g of 4 equals -2. So which one is greater, -1 or -2? -1, so we're going to say column A. And that concludes Unit 2, Topic 1 of the Algebra Exam Review.